Greetings of the day. This is Muthulakshmanan from Mechanical Department. I am working here as an assistant professor for the past 3 years. I wish to explain about the non-conventional machining process in this session. Let us explain what are all the contents that contain in the non-conventional machining process. I'm telling about the flow presentation. So the flow presentations are introduction part, then application of the non-conventional, or it can be called as non-traditional machining process, then why we are using it, what is the need of using a non-conventional machining process, then comparison of conventional machining process and non-conventional machining process, then how we can classify it, what are all the examples for different types of non-conventional machining process, then how it works, that is called as working principle, then what are the process parameters we are going to consider for the better machining output, then what is the main advantage, and what are the major limitations, disadvantages, all those things we are going to discuss in this non-conventional machining process demo. Okay, so the first, let us see the introduction of a non-conventional machining process. So these are the process which are developed initially to machine a very hard materials. Whenever we are considering the hard materials like a diamond. Okay, so how we can operate a diamond? How we can machine a diamond like hard materials for the application of any other mechanical oriented or the common usages. Okay, that are most these are almost impossible to machine economically by conventional methods. Then how we can utilize the ability of the cutting tool to stress the material beyond the yield point to the start the material removal process. So this requires that the cutting tool materials is harder than the workpiece material. So whenever we are thinking about the new materials, so the new materials has to be machined in a manner such that high strength to weight ratio, heat resistance, hardness, such as neamic alloys, then alloys with mixing elements like tungsten, molybdenum, and columbium, or these are all the major elements that we can mix with and to make composite materials, which are all very difficult to machine by traditional method. So next, the complex shapes. After the hard process, okay, hard to cut the materials. Another important factor is the complex shapes. If you want to do any complex shapes, that is also not possible in the traditional methods. So we are moving to towards this NCM, that is non-conventional machining process. So besides of the complexity of the surface, the high accuracy is to be desired. So that is also possible here. So these processes are not meant for replacing the conventional, but in fact supplement them. We can all based on their requirement. So whenever we need the hard to cut material, then we can choose this non-conventional machining process. And whenever we are in need of complexity, machining in the complex uh, shapes or surfaces with the high accuracy, then we have to switch over to non-conventional machining process. However, the non-conventional machining process depends on the number of other factors also, that is the vaporization of metal, electrolytic displacement, chemical reactions, and mechanical erosions. Then let us see the purposes. What are the purposes of the non-conventional machining process? In other words, we can say why we are using the non-conventional machining process. So we have discussed just now. Additionally to that one, we have many points. The major points are high strength alloys, complex surfaces, higher accuracy, and surface finish. Then difficult geometry, and then it can be included for automation. So these are all the major purposes of non-conventional machining process. Then let us see the comparison between conventional and the non-conventional. So what are the differences or what are the similarities are there, when we are going to see now. Direct in conventional, there is a direct contact of tool and workpiece, but in non-conventional that is not possible. Uh, so that is not happening. Okay, not possible is wrong. What that is not required, that is correct one. Okay, then cutting tool is always harder than the workpiece. So here cutting tool in the conventional one, for example, if you are taking lathe, the cutting tool we are used to take a HSS steel. Okay, so that steel will be always hardest, we are choosing it for operating a mild steel component. Okay, that is an example for that. Then tool life is very poor due to high wear. Okay, then generally microscope chip formation will also occur. Then MRR, that is a material removal, takes place due to the application of cutting forces. Then it is the convention is suitable for all the material. It cannot be used to make prototype parts very effectively. Then to see the non-conventional machining process, here the tools are a non-conventional technique. So how it is a non-conventional technique, that is a laser beam or electric arc. So what they want to tell is there will not be any direct contact between the tool and the workpiece. For example, if you are taking in ultrasonic machining, the ultrasonic waves will hitting on the surfaces where I want to machine, and that will be removed from the that will be the process. The process will be taken like that only. Next, the tool may not harder and it may not be physical presence. Okay, then due to this non-contacting process, the tool life is more compared with the non-conventional method. Material removal rate, MRR, that is will also happening here without the chip formation. Why? Because that in conventional, the major disadvantage is the chip formation, which will affect the tool as well as the workpiece and the entire surface also. Okay. So but here we don't have those disturbances, we can say that is as disturbances only. So it uses different energy like electrical, thermochemical, etc., and it is not suitable for all the material. That is one of the limitation in non-conventional machining process. And it can be used to produce prototype parts very effectively, that means in very accurately, particularly in aerospace parts, we can um, explain, we can do in an accurate manner. Then it is classified into several types of major category. That means we are going to see the classification of the unconventional machining process. So the first one, the mechanical energy based. The examples are abrasive jet machining, water jet machining. Why we are telling this one? Because the energy is mechanical based. Through kinetic energy, heavy water pressure, the water will be impacted. It is allowed to hit on the surface of the material. So that's why we are classifying this one under mechanical energy based. Next one is electrical energy based or electrical energy based. So the example is EDM, through electrical heavy supply, power supply. We are removing the material. Then third one, electrochemical energy based, so ECM method. Example is ECM method. Then electrical energy based. So that is the plasma arc machining also. So like this, we can category. Then based on the source of energy. Okay, so source of energy are current, voltage, hydraulic pressure, pneumatic pressure, ionized particles, light. These are the sources of energy. Based on that one, we can classify it. Then based on the medium of energy transfer, the electrons, atmosphere, ions, electrolytes, water, pressurized gas, then ultrasonic waves, then chemical reaction and radiations. So these are all the medium of the energy transfer. Okay. Then based on the mechanical mechanism of material removal, so erosion, electric discharge, shear, vaporization, melting, and many like this, many based, we can classify the non-conventional machining process. So in this one, we could not explain all the machining process. Now let us see what are all the major machining machines which are all in current usage of by the many researchers, that is EDM, ECM, ECG, USM, laser beam, LBM, then chemical machining, CHM. Okay, then the important one is abrasive water jet machining. Okay, so these are all the major unconventional machining or non-conventional machining used by our current researchers. Okay, now let us see any one of the given non-conventional machining very detailedly. So what we are going to see is the water jet machining process. So in this process, from the name itself, it denotes that we are allowing the water at the highest pressure uh, to make the hit on the surface of the material, required material. So once the water hits at a high pressure, what do you mean by high pressure? In the tap, we will be getting a, 2 bar or a 3 bar pressure. Okay, so but here we are going to focus on nearly 4,000 or 5,000 MPa megapascal pressure we are going to allow on the material such that uh, where I want to remove or machining the whether either it may be drilled one or we can partially drilled or button type one, or we can go for surface finishness. All those things we can perform by using this water jet machining. So why, first of all, why, what is the reason for using this water jet machining? First of all, we are not going to affect the material properties. So first of all, whenever we are using the same material with the EDM process or any other ultrasonic, a heavy due to heavy heat supply, the properties of the materials will get disturbed. But whenever we are using this type of material, okay, abrasive water jet machining or water jet machining, the properties of the materials will not get disturbed, as well as it is a eco-friendly process. So that's why I want to explain this water jet machining. So the introduction, what is the introduction? Yeah, about this, how we can explain, this is one of the most famous non-traditional machining process. It is a eco-friendly or environmentally friendly because it uses water for cutting process, no other side effects and all. Okay, then abrasive jet machining is a mechanical based one, because we are going to, whenever uh, you are using a hard materials, that time we are adding the abrasives along with along with the water, so that will make us to remove the material. It helps us to remove the material effectively. Okay, um, so now I can compare this in water jet with the ultrasonic or laser beam. Whenever we are going for ultrasonic or laser, no, so that laser that will affect the person who is operating that machine. Okay, so that type of process, the type of accidents will not happen in this water jet machining. But handling is very much important, because high pressure water, if he are not taking care on his process, it will affect his health also. Okay, some unexpected accidents will also happen. Okay, so in this machining process, high speed stream of water jet impinge on the workpiece, which removes the metal from contact surface by erosion. Okay, it is mostly used to machine soft materials. Okay, it can cut hard materials, but we are using for the soft materials. Why? uh, some materials like brittleness property, having the brittleness property like glasses. Okay, so we could not cut it. Even if you go for cutting, no, that brittleness will expand to another nearby material also, so the entire material get damaged. So that can be avoided by using this water jet machining. So where I want to do that profile, we can take it completely, and complex shapes also we can produce with the help of this water jet machining. For machining hard materials like carbide, ceramic, abrasives also, it can be entertained. Both the process working on the same principle, I mean water jet as well as the abrasive water jet, But what is the difference? We are adding abrasives with the water if it is required. If we for cutting and cutting rocks and all, we are in many places we can observe the water jet only. Okay, so it all depends on their usages or applications. It is mostly used in mining industries, then aerospace industries for cutting the record shape. Then what's the working principle? Just now we have explained. No, so the same working principle. Detailing, we can see this process works on the basic principle of water erosion. In this process, a high-speed, well-concentrated water jet is used to cut the metal. It uses kinetic energy of the particle to erode metal at the contact surfaces. The jet speed is almost 600 uh, meter per second. Okay, per second it is 600 meter. That is the speed here. It does not generate any environmental hazards, as I told you earlier. For cutting hard materials, abrasive particles are used in water jet. The abrasive particles erode metal from contact surface. So let us see the water jet machining, the parts, how it can be remove the material detailing. So yeah, there will be a water filter. So in this water, through water filter only we are supplying the water. So here in the water particles, if it is contains any dust or anything, so it can be removed, it can be filtered out, and after that one, it will be allowed to pass into intense sphere. So intense sphere is the unit which makes the water in highest pressure. Okay, so the outlet of the intense sphere water will be a high pressurized water. So that water is allowed to go into that mixing chamber. That mixing chamber, if you want, we can add abrasives usually. Otherwise, we can directly allow to that focusing tube, and that focusing nozzle will directly kept in the terms of some standoff distance. Term is there, that parameter we have to follow. So that by using that one we can do the machining process. Okay, so that standoff distance is nothing but the distance between the nozzle as well as the workpiece. Okay, so it is an important parameter. Based on that one, we can get the surface roughness and many other output responses. So in the mixing chamber, if you are skipping abrasives, no issues. Suppose if you are adding abrasives, a separate abrasive feeding hopper has to be kept, and from that abrasives hopper we are supplying the abrasives slowly into the mixing chamber. So in the high pressure water as well as the mixing chamber, both it will get mixed in the mixing chamber, and directly it will go and hit the surface of the material for the material removal process. Okay, so this is the working principle of the abrasive water jet machining. Um, so what are the equipments we have seen now? So the important equipments it is required for the process is hydraulic pump, hydraulic intensifier, hydraulic accumulator, then tubing system, flow regulator, nozzle. Then if you want to drain the used one, so drain and catcher everything are the major equipments present in this water jet machining, non-conventional machining process. So what are the process parameters we are going to use here? Abrasive size, how much abrasives we are going to allow? It is a 25 micron level we need to use. Nozzle diameter, how much it is? The nozzle diameter it is 0.13 to 1.2 level we can use it. So when we are using this normal nozzle diameter and abrasive particles under 4000 MPa, then what will be the MRR, material removal rate? That is a zero point 0.8 cube per minute. Then how much the level of surface finish we will can get is zero point 0.5 micron level, or up to 1 we can vary it. Okay, so very less surface roughness is required for us. So zero point 0.5, even 0.5 micron level also we can achieve by using this water jet machining. Next, what are the major advantages of this water jet machining is that it does not change the mechanical properties, as I told you earlier, does not change the mechanical properties of the workpiece. It is useful for machining heat sensitive material. It is environmentally friendly. Okay, so eco-friendly, it is called as eco-friendly because it does not form any dust particles and use water as the cutting fluid. And again, once the used water also we can recirculate, and we can allow for after doing some filtering process, we can allow it for that operations, we can reuse it also. So eco-friendly, mean environmental hazardous is a very important one. So if it is any material, if it is hazard to environmental, that is has to be stopped immediately. Already the plastics we could, it is ruined out. Okay, many of the researchers what they are telling, we are inhaling the microplastics every day, and in our entire life we are using, it is going up to 2 kg 3 kg microplastics. Okay, so that has to be stopped, which are all the hazard to our environmental for the betterment of the future next generation. Okay, next one is good surface finish. It is having it gives good surface finish. So, just previously I have told, the up to 0.5 micron level we can go, but research is going on to improve the surface quality. Okay, and no physical tool is required, there is no physical tool. Okay, nowadays the automation is also included in this water jet machining. Okay, it can be used for cutting both soft material as well as the hard materials. Now, what are the applications of this water jet machining here? It is used in aerospace industries, as I told previously. It is used in aerospace industries. Abrasive water jet machining is used to cut metals like stainless steel, titanium, inconel alloys. Also, we are using that one. It is used to machine or cutting reinforced plastics also very easily. Then used to cut stones, which reduce dust in environmental. Okay, so then drilling and cleaning and polishing of hard surfaces also can be applied. Then to machine intricate shapes, okay, complex shapes, that the intricate shapes also possible in this water jet, abrasive water jet machining. Okay, then let us see the important one, that is the limitations. What are its limitations? We have seen till now, we have seen many advantages, but limitation is also there. Okay, so what are the initial what are the major limitations? First of all, high initial cost, we need to invest more. Okay, for this non-conventional machining process, water jet machining process, the limitations. Okay, it is common for all the non-conventional machining only. Then it cannot be used in machining materials which degrade in presence of water. That means it can be used by a skilled labor is required. Okay, then sometimes we may get a very low material rate, removal rate also, so that can be improved. But if you improve, what is the difficulty we have to face is the surface roughness. Okay, so then the thick material cannot be machined easily. So for that purpose, we are in need of skilled labor. Okay, uh, okay. So up to this topic, we have seen then example of non-conventional machining process. So non-conventional machining process, it is a it's one of the abrasive water jet machining is one of the non-conventional machining process, and it will be applied, it can be applicable for many operations. Okay, in futures. So the researchers, many research are going on based on this topic, and for the improvement of surface roughness, and to complete the complex shapes or like intricate shapes. So mm that's all about the non-conventional machining process introduction, as well as the major content. So thank you, one and all.